So this is another example of an equation involving a pronumeral which is as an exponent. Now this time we have a slightly more challenging situation. I do have here 16 as a base, then I have 4 as a base. I notice that that could be 2 squared, and this could be 2 to the 4th power, so I might start to think expressing everything with a base of 2. The trouble with that is that I can't think of a power of 2 that equals 24. So I'm going to have a different approach here. My different approach this time, I also note that 16 is 4 squared. So that gives me a clue. Let's express this as 4 squared, still to the power of x, minus 5. And I'll write this 4 to the power of x, just with brackets to keep it a little bit separated nicely, equals 24. Now when it's power of a power, this would be 4 to the power of 2 multiplied by x. And when we have 2 multiplied by x, it's just as good, equally correct, to say x multiplied by 2. So 2 times x times 2, that's commutative law. We still have here 5 times 4 to the power of x, and I'll subtract the 24 this time, leaving equals 0. Now it may not look like it yet, but this is actually in the form of a quadratic equation. I'm going to, apologies for that bump there, I'm going to make a replacement, just to keep things a little easier. I'm going to say, let 4 to the power of x equal, let's go q. And rewriting my equation then, I would have q squared minus 5 times q minus 24 equals 0. Now I have to solve this quadratic. I think it's a monic, positive 1 here for the squared coefficient. So I need numbers that will add to negative 5 and multiply to negative 24. I know that 3 times 8 is 24, and 1 would need to be negative to produce a negative product. So I think I've got it. We would have q minus 8 multiplied by q plus 3 equals 0. Let's double check. Negative 8 plus 3 is negative 5. Negative 8 multiplied by 3 is negative 24. So now that I've solved it, we use our null factor law. Q could equal positive 8, or Q could equal negative 3. It's time to bring this replacement here back. So we know Q was actually 4 to the power of x. 4 to the power of x equals 8, or 4 to the power of x equals negative 3. Now, this is a little bit like the previous one. I have numbers on either side of the equal sign, the left and the right hand side. I'll express them both with the same base. 4 is the same as 2 squared to the power of x. 8 is the same as 2 cubed. Now this one's a bit difficult, isn't it? Can I think of a way of expressing 2 to some power that would equal a negative number? It doesn't exist. 2 to any power is going to be, so if I was to try to do this, if I was to go 2 squared to the power of x equals 2 to some power, there is no number that I could write here which makes 2 to the power of something equal to negative 3. This is an example of a solution that doesn't produce a result. So that one stops. This one we finish. We have 2 to the power of 2x equals 2 cubed. Therefore, beg your pardon, that symbol actually is implied, not therefore. So we have 2x equals 3, x equals 3 over 2, or if you're a fan of decimals, 1.5. We should verify the solution, as we always do, and to see if you can... I really do have to do something about that fluorescent light above my desk getting in the way. I hope you can see the screen all right there. Just clear everything away so you can see it a bit better. Now what do we need to do? I don't know if that helped or not. We need to try this original equation. 16 to the power of 1.5 minus 5 times 4 to the power of 1.5. And it says it should equal to 24, and there it is, barely visible on the calculator screen, 24. That's all. See you in class.